So again, I think one things that we mentioned is the obviously thickness,
right?
And so that you can basically put more layers inside and still maintain your overall board thickness. The other thing too is that reliability. By not having discretes on the surface, there's nothing there that can fail. Every component is potential failure. One of the common defects on very small components is tombstoning, where it basically pops up after assembly or something during assembly. Well, that doesn't. If you don't have a component, that can't happen. And so, and you're eliminating those vias. And so, in fact, some studies have been done where some discrete capacitors were put on the surface and put in an oven with a board that used embedded capacitor technology, and they were cycled. And the discrete capacitors failed much quicker than the board never failed using the embedded capacitors, but the discretes eventually failed. And so from a reliability, in fact, there's one manufacturer actually uses buried capacitance technology in their black box for their flight recorders because of the
the reliability
and reliability. So it is so that's another aspect of the technology. And also, like you mentioned earlier, the placement of the remaining caps. Again, studies have been done showing that once you have this efficient power distribution network, you can actually place your remaining caps further away from the components, from the chip package, because it'll still get the energy it needs in the time allotted because it's much more efficient. And so it gives you some design flexibility. Lots of times you look at boards, you see everything crammed in the same general area next to the package. This gives you a little bit more flexibility from that respect. Other thing too is that when we put these power and ground planes close together, it actually has a dampening effect on any resonances that can occur in that power or ground plane. So when you think about it, the ICs are switching faster and faster, and that energy, it basically goes into the power plane, and that basically at the higher frequencies, it can actually turn some of the components into basically radiators. And it can also, off the edge of the board, you can have some radiation coming out between the power and ground plane. And it turned out that if you take those layers and put them close together, you greatly reduce the amount of emissions coming off the board. And again, I did a study many years back where we took it was a relatively simple board, it was only a 10 layer, but we put it we built it the traditional way and built it with buried capacitance technology and put it in the chamber and measured what was coming off of it, and there was quite a significant reduction in the emission. So that helps with again, you can either minimize or eliminate possible shielding from these from some of these boards.